Okay, so this is problem 1, the second method for proving that this is that the diagram that we have right here is a non-square rectangle. All right, so it's telling us, here's another way you could do it. You could show that the diagonals are congruent and that they bisect each other. Remember, that was one of the properties of rectangles, but that two sides are not congruent. So this is the part that's going to show that they are that this is a rectangle, and then this is the part that's going to show that it's not a square. Now notice, we did this already in the previous step. I'm not going to repeat that. All right, we showed that they're not congruent right here when we showed the AD and CD. The length of AD was square root of 153, and the length of CD was square root of 17. So I'm not going to do that again. But had we not done this part already, we would have to do that. But we'll just make mention of the fact that we know that their lengths are different, but we're going to focus on doing this part. All right, so we want to show that the diagonals are congruent. In other words, that they have the same length, right? So this is going to be distance formula. We want to show that they bisect each other. In other words, we want to show that their midpoint is the same. So if they bisect each other, this point E right here splits these into two congruent segments. All right. And then if this is where they intersect and they bisect each other, then these two should be congruent. So really what we want to do is show that E is the midpoint of both BD and AC. Okay, so this is going to come from the midpoint formula. Okay, so let's do that. The diagonals are congruent. So we're trying to find the length of BD. All right, so we're taking the difference of the x coordinates, so 7 minus negative 4 squared, plus the difference of the y coordinates, which would be negative 4 minus 3 squared. 7 minus negative 4 is 11, and 11 squared is 121. Negative 4 minus 3 is negative 7 squared is 49. And 121 and 49 is 170. Square root of 179, and 1 is 0. Carry the 1. Yes. Okay. All right, and then we are hoping that AC is also square root of 170. And again, notice I'm not reducing or changing it to a decimal. I just need to see that we get the same number under there. All right, so let's do it again. So I'm taking for here, I'm taking the difference of the of the x coordinates, so 8 minus negative 5 squared, plus, and then the difference of the x coordinates, which would be 0 minus a negative 1 squared. All right, 8 minus 5 is 13. All right, 13 squared is 169. And then 0 minus a negative 1 is 1 squared is 1. And 169 plus 1 is 170. So yes, the diagonals are congruent. And then we're trying to show that they bisect each other. All right, so we want to find the midpoint of each of them and then show that it is this same ordered pair. All right, so the midpoint of BD, we just have to take, remember the formula for this is x1 plus x2 over 2, comma, y1 plus y2 over 2. So we're going to use the coordinates that go along with BD. So we've got negative 4 plus 7, I'm just using the x coordinates of B and D here, over 2, and then 3 plus negative 4 over 2. Negative 4 and 7 is 3, divided by 2 is 3 halves. And then 3 plus negative 4 is negative 1 over 2 is negative 1 half, which is what we guessed it was right there. All right, and then the midpoint of AC, same thing. We're going to take the average of the x coordinates. So for AC, we're going to go with 8 plus negative 5 over 2, and then 0 plus negative 1 over 2. 8 and negative 5 would be 3 over 2 is 3 halves, and 0 plus negative 1 is negative 1 over 2. So the midpoints are the same. which means that they bisect each other because the midpoint of this one is also the midpoint of this one. Okay, and again, the third thing that we would have to do is show that two adjacent sides are not congruent, which we did. So we're just going to recycle this information from the previous problem. But again, if we had not done this previous problem already, we would have to do that step right here. Okay, so again, on another sheet of paper, I'm going to write the summary there. So to show, to prove that ABCD is a non-square rectangle, we showed that, so I'm just looking back at the cheat sheet right here. We showed that the diagonals are congruent and that they bisect each other. So this is kind of like, actually, wait. This was not the way that we showed it for or that's not the way that it says to do it in the rectangle on the table. We're doing kind of a combination of the parallelogram and really something that's not even listed on here. So we're going to show that the diagonals are congruent. This is a property of rectangles, all right? Again, it's not listed on that sheet, but if you go back to whatever chapter that was for quadrilaterals, chapter 6 maybe, I can't remember. That is a property of rectangles. We're showing that the diagonals are congruent. We found that BD equaled AD, which equaled the square root of 170. This shows gosh, I should have gotten that page out. Because it's not enough to prove, it does not prove it's a parallelogram when they're congruent. I think this shows that it's a rectangle. I'm going to have to come back to that. I think that it shows that it's a rectangle and that they bisect each other. So then we showed that the diagonals bisect each other. By showing that each diagonal's midpoint was 3 halves, negative 1/2. We showed that it was not a square by showing AD did not equal CD. We got square root of 153 did not equal square root of 17. All right, hold on for just a second. I'm going to get my book out and check to see what that says so that I don't have to say it on the next video. Getting out my very big binder here. Flipping to that table. So the table that I'm talking about is the one that is on page, it's our favorite. Okay, here we go. Pages 93 and 94 in your workbook. And in a rectangle, yeah, the diagonals are congruent. They're also congruent in a square, and the diagonals do bisect each other, but they also bisect each other in in parallelograms. So congruent diagonals that bisect each other guarantees, the two of them together guarantee that it's a rectangle. And then the fact that the two sides are not congruent would mean that it's not a square. All right, if I come up with something else on that, I will let you know in the next video. All right, bye.